All right, I'm going to start because we got a lot to cover, and I'm going to go as fast as I can. We're going to talk about some microservices on .NET. To set the stage, I'm running Windows on a Mac, and I go to a RHEL VM, so I do everything I can to break it. So let's see if I can break things. So, and we all know that. First thing I've got to figure out how to use a slide. So why are we doing this? Who cares about .NET and containers? I mean, what's the big deal? Well, here's why. There's a transition in the software industry, and we all know this. And I was just talking to a former colleague today from another company, and they're a hardware company, and she said, everything's software now. Like, we're not even doing hardware, we're doing software. So there's this, we talk about the digital transformation, and that's a buzzword, but it's true. I mean, everything's becoming software, or the software's changing. And I think people say don't get Uberized. I'm not sure what that means, other than get picked up and given a ride somewhere. I always say don't be a Blockbuster in a world of Netflixes, because to me, that's the biggest example of going from hardware to software, right? So if anybody ever worked in the upper left, I don't know left from right, left quadrant there with the waterfalls, do you remember the requirements document, the design document, and the functional analysis and all that stuff, and RUP and all that fun stuff? So we went down to DevOps, where everything just happens now, or should. And we went from the monolith to microservices. I was doing microservices back in the late 70s, only because the machine had 27 megs of RAM and 27 megabytes of disk and 24K of RAM. So every program was a microservice. But it wasn't the same, obviously. We went from physical servers. I remember standing in front of a rack of servers and installing .NET and taking all day or all weekend or all Saturday when I felt like all weekend, to where we did virtual servers, and we thought that was cool because you could spin something up in a few minutes, and I'll cover some of the fun stuff with that. And then we got to containers, where everything just, hey, containers, great. It works in a couple of seconds. I can go home. And then the data center down to the cloud. Everything's the cloud. And even some people I know that don't know anything about technology are like, isn't that just somebody's computer? I'm like, shh, don't talk about that. So some of the issues, software's too complex. Are there any .NET developers in here that use Visual Studio? Right, so the example I use, your first day in a job, like they sit you down, Visual Studio, here's the solution, you open it up, it's like, oh my gosh, there's 42 projects. So someone goes to the whiteboard and draws a bunch of lines and squares and circles and arrows, and they're like, okay, that's kind of what we do. And that's where we are with software. Deploying takes forever, and in IT, that's a couple of hours if you're lucky. But I mean, when you talk deployment, I'm saying, well, let's change this until it actually is in production. It does take forever. And then setting up a VM can be interesting. So remember a few years ago, the thing was, and I worked at this cloud company, it's like, hey, you want to scale? You can spin up another VM. So I was working in the Microsoft stack. So I'm like, I'm going to spin up a server, Windows server. It took 20 minutes. Like, yeah, that's a really good scaling, is it? And also, if you spin up a VM, who in here could guarantee that the VM they spin up would be exactly like the one that's running? There's one, right? So there's the wild exception. I mean, the same dependencies, the same versions, everything. They're like, oh, well, we use Ansible or whatever. That's great. Then you are organized. But typically, it's really interesting. So containers to the rescue, and there's question marks because, like everything else, there's issues with that, right? We have a tendency as people just to look for the silver bullet. So I'm going to do a very simple microservice that returns the host name. It's written in C#. I have examples on my repo that are written in F#. So there's that. I got that going for me, which is nice. And then we're going to stick it in a Linux container. Real basic stuff. And does it scale? It scales easily if we use Kubernetes. And OpenShift is, kind of like if the OpenShift people plug your ears. It's a wrapper around Kubernetes, from my standpoint. If you aren't familiar with Kubernetes, K8s, that's the hipster abbreviation for it. So Google wrote it to manage containers, and I say that because they don't use it, but it's still good. I'm not dissing it. Rolling updates are supported, which is really cool, which basically means you have a program running and you just create the new version and it just rolls it into place with no downtime. And then zero downtime deployments, and there's a couple of models for doing that. So let's do a demo. Let's run our microservice, put it in Docker image, and do some scaling stuff and show some port conflict stuff. So here I am in a VM. It's RHEL 7. We have a thing called the Red Hat Development Suite, and if you're a developer, you get it for $0, which means free. We call it $0. I don't know why. It installs really. I had a discussion earlier with someone else at Red Hat about, oh no, it's not as good as something else. I'm like, you know what? From a Windows developer, it's great. I just download it, install it, and it works. So I don't want to mess with this stuff. Like if you're new to Linux and you're a Microsoft guy, you don't want to mess with stuff. And this you don't have to mess with, it just works. And there's videos how to use it and everything. So the first thing I want to show you, which is really interesting, is my Docker file. If you're not familiar with Docker, and it's kind of like a tiny VM, and you build layers. And if you are familiar with it, and even if you're not, if you look at my Docker file, nowhere in here do I install .NET. So that's the first thing. I'm going to run .NET programs and containers, and I'm not installing .NET. That's pretty cool. .NET Core now allows you to publish applications, which means you can take an application and build it from any operating system to any operating system, and you don't need .NET installed where you're running it. So I can build a Windows app in RHEL and run it on a Windows machine without .NET being installed. That's pretty cool. And it works great with Docker because I can just use RHEL 7 as my base image. I install a couple of dependencies, that's a fact of life, and then I just copy my code over and we're ready to rock and roll. Now, the hardest part of my demo is getting out of Vim. Okay, yes, I did it. So if I do a Docker build, and this goes really fast because I've done it so many times, right? So everything's cached. So we have a thing called Atomic Host, which is a smaller version of RHEL for like containers. And I'm experimenting with that to get an even smaller image. My image that I just built is, I think it's 287 megabytes. Yeah, we can see that, Don. It's right there at the top. It's 287 megabytes. When I used Atomic Host, I got it down to 130. But there was something missing, and someone made the joke, yeah, I was missing the 150 megabyte part that you need. So I don't know if that's true, but I'm working on that. And the reason I tell you is you can follow me on Twitter and stuff and kind of bug me about it and see where I am. And I will follow up, because that's a goal, right, to get it as small as we can. Microsoft has talked about, and we'll hear about this later, efforts to reduce that. So I have an image built, Docker run. I'm going to run it like locally to my command line. So it's going to run at port 5000. If you develop in this environment, I have a VM in Windows, just a little thing that caught me the first time I did it. You can't do it on localhost because your VM is your local host. So when you go over, like to here to look at it, you wouldn't see it. So I have asterisk port 5000. So it shows up anywhere. One of the cool things now about .NET Core is you can specify that URL as an environment variable. So there's the first 12 bytes of the Docker image. So that's just to show you that it's running in Docker. And forget the V2. There's a longer demo where I bump up the versions, but we're pressed for time. You'll see that the versions are different. It's just more impressive when you have V1, V2. So there's that. So that's just a proof to say, hey, it works. And then I can go over here and Control-C out of that. So if I do a Docker PS, it's not running. There's a bunch of stuff running there because when you get this development suite, you get Kubernetes and you get OpenShift and all that. So that stuff's all built in. It's pretty cool, right? I mean, you start up this development kit and you have all this great stuff to play with. And then you can just like wipe it out and start over, which I do all the time. So that's a great environment. So the next thing I want to do is I want to talk about there's a deployment scenario called blue-green deployment. And basically it is, the colors don't matter, but you have a version running, and then you want to replace it with another version. So let's go version, 4 to 5, let's say. And so you do that, because you've tested everything, you know it's going to work, it's not a problem. So you do it. The one thing you want is no downtime, and the other thing that you want is, if you go from version 4 to version 5, if you go from blue to green, you want to be able to say, oh my gosh, if something bad happened, I want to be able to switch back instantly. So one of the things you get with this suite, with Kubernetes and OpenShift and all this, is you get software-defined networking and routing. So you're not relying on hardware, it's just commands. So of course I have everything scripted because it's a demo. So let me show you quickly the create green. So it's called blue-green, right? So of course, I don't know right from left, so I do green first and then blue. I get stuff confused all the time. So basically what this does, this is OpenShift commands, OC. So if you're not familiar, here's what it's going to do. It does a new build configuration, which basically says, I'm going to build stuff and here's how I'm going to do it. And then the start build is it's a binary build. I'm sorry, the new build is a binary build, which is basically a Docker image. You can also do a build from source, or it's called S2I, the number 2, source to image. And you can pull like from Git. So you could do that. I'm doing binary because I have to pick one. And then you start the build, and the -- follow just says, it's kind of like the verbose thing. And then it creates an app which is like a pod in Kubernetes. So over here, the web console is where I have this. So OpenShift has a web console, a dashboard. So the first thing I need to do is I need to log into this. So I will log in, and of course I got the password wrong. So I'm going to create a new project. Now you don't have to do everything at the command line, but if you see in the background, now I have it there. So obviously you can work at the command line, it's reflected in the dashboard. So that's kind of nice. You can kind of get a visual feedback, but you can stay at the command line, which is where you want to be, right? Because you're going to script stuff. So if I go into this now, there's nothing there, which is of course. So if I do the again, well, I showed you how it builds. Let's just go ahead and run it. So create green is going to create this application. So it's going to do the build, which is the Docker image. This time, instead of the Docker image being in my PC, it's inside of OpenShift. Right? It has its own repository. It just so happens that OpenShift is on my machine, so physically the same little magnetic bits are on this machine, but it could be OpenShift running, in Azure, for that matter. You understand? So that's where the build would be done. So it's built. So if I go over to the dashboard, I should see it. And I can. Now the problem is I can't get to it. There's no URL, no URI. There's no route to it, which is up here. I'm not going to, hopefully not click on that. I'm going to do this, OC expose, and I expose the service. So it's a web service, right? And I call it .NET Hello. And when I mash that, I should now be able to go back, and there is a URL. And what I have over here is an application that this is PowerShell in Windows. So I'm trying to throw as many things into the mix to show you that, hey, it's open source, everything works together. So this is hitting it every second and watching it. So it just turns the host name. Now remember last time it was 12 bytes of the Docker image. Now I'm getting the OpenShift, the pod from Kubernetes. So that's this one right here. So if I scale this up to 2, for example, and it takes like 4 seconds, now I have 2 of them. Now you see 2. So the first thing you see is you can scale real quickly, and you can script all that. You can set configurations that the scaling kick up and down kicks off automatically and all that stuff. But you see, I went from 1 to 2 just like that. And this is on a laptop. This isn't a server. And again, this is all .NET. This is C# code. This is no, and remember, I did not install .NET. That's pretty cool. So that's running away. That's great. So let's go back over here, and let's do it the next version. Now we did blue-green, that was the green one, so let's do blue. So of course I have a create blue script. And if I run this and as things go well, in the background you're going to see .NET Hello -blue. Now again, in a longer time of a demo, I would go in and edit the code and rebuild it so it would say like version 3. But you'll see the change in the PowerShell window. And there it is. So now I'm running on the new version. Notice there was no downtime. At no point did I get like service not available or anything. So that's cool. And that's, thank you Kubernetes, Google, that's awesome. Now I have one of them running, whereas the other one had 2. So I can scale that up if I want. And I'm going to scale it up to, 4. And I'm going to take, I'm going to do this. I'm going to switch back to green because I'm running blue, right? So there's blue. Now let's see how long it takes to switch back to green. There. It was that quick. So now, and I can switch back to blue. And there it is. So that is the scenario where you say, we deploy our app, but we want to kind of have a backup plan in case something goes wrong. I mean, I know nothing ever does. If you're like me, a developer, when you leave on Friday and give it to the DevOps, the operations people, you know it's going to be fine. So there's your Friday 5 p.m. deployment. So we are now in the blue, which is our next version. Now I'm going to show you what's called the Canary deployment. The Canary deployment is where, it comes the old canary in a coal mine, where you roll out. Well, the canary was, you go in the coal mine, right? You have a little bird there, and it sings and everything. When it stops, you knew to get out of the coal mine, because there was either natural gas, which is odorless, even though it doesn't seem like it is, but it is, actually, or carbon monoxide or some poisonous gas. So if the canary died, you got out of there before you did. So this scenario, we're going to put the application up and just give it to some of our audience, right? And if it fails miserably, we back out and say, okay, that was a mistake. But if it works, then we're going to give it to a little bit more of our audience. And if that works a little more, and eventually the idea is it kind of overtakes, like say we're going from version 3 to 4. Version 4 overtakes version 3 and it becomes the new version. This is kind of a gradual way to introduce a new version with a fallback. Rather than the blue-green, which is like all or nothing, this says, yeah, well, let's just kind of give it out slowly. And there are tools that I don't have on here. I can't remember, I think it was like Etsy or something. There was a tool that could do routing, and it's pretty cool. No, this isn't doing the routing per se. I'm just going to do the application and the scaling. The routing is a different story. In other words, how you control who gets it. Like everyone named Jason or something like that, or all the customers in this state, or we have customers over certain revenue or under. I don't know. That's a whole nother issue. This is the infrastructure that we're going to do with that. So I have Canary create. Now let's make sure I get this right. So we're cranking away in the background. That's cool. And by the way, over here, you can see that there's 4 here and 2 there, and we're running the 4. Everything's good. So I have one called Create Canary. So the Canary build, I start that off. It's going to do another build, and you're going to see the word Canary in there to try to make it, noticeable for our sake. Now, when this runs, we're talking about zero-downtime deployments. So the idea is, then the service went down. So something obviously went wrong. If you see in the background, you see it scaling here? So this one's scaling, and stuff's moving. But over here, wait, okay, now we're good. So there was some time when the service was down. Now what's the deal with that? Well, there's a couple of things. Kubernetes has this thing called a readiness probe that you can tell the system, like, don't even bother with this pod until it's ready. Okay, the first example I had that set. In this example I did not, and I'll show you why in a minute. But if you see the Canary now is just one of many in there. You see how that's popping up? Now if I go over to this dashboard, and poke around. There's the Canary. So let's take this 4. I have to be careful because sometimes I bump the trackpad and it takes it as a key click. I'm really more of a mouse person. I'm going to scale this one down to 2 and scale the Canary up to 3 and see what it does to the mix in the background. And again, this is a laptop computer. This isn't a server. And by just doing that, now you can see the mix is changing. It's going to be more, I think it's about even now, maybe more toward the Canary build. So there's your Canary, and you can adjust it by doing the scaling. And it could have been zero downtime, but it wasn't. But that's by design because I want to show you one more thing before I turn this, and I'm making great time, turn this over to Scott. And that is what's known as the circuit breaker pattern. So speaking of breaking, let's break this. Let's get out here. You know what? Here's every operation person's nightmare. OC, delete, project, my.net, and then cascade, which basically says just go down the chain and get rid of everything. This is my favorite part of the demo, and just kind of a warped sense of humor, because I like to do this and watch everything in the background just go away. I just get a kick out of that. So it's gone. All the work I did is gone. Here's a point about that, though. All the work is gone, but I still have, look at this. I wiped everything out, right? No, I didn't. I still have all the images, all the Docker images. Here's the beauty of containers. Right? I didn't lose anything. I just stopped running it. Images are immutable. They don't change. The whole idea of immutable infrastructure is that you never change your application once you have it built. Well, you never do. You always rebuild it. But the point is, an image, it doesn't change. Like if you want to change something, you rebuild it and you have another version. It's immutable. That image runs the same everywhere. I don't have to worry about spinning up a VM and hoping they match. I just do another image. Even though I blew everything away, so to speak, as long as I have these images, I can rerun them and I'm going to get the exact same code. That's fantastic. And again, it's all in C#, but it could be F#. I'm using stuff out of the box. If you've heard of Nancy FX, that works great too. So there's a project called the Poly project. I'm going to go over that and show you. And this is a pretty mature project. I think it's like on version 5. And what it is, it allows you to implement the circuit breaker pattern. The circuit breaker pattern is like the circuit breaker in your house. So I'll give you the example that's very real to me. I did some outside wiring, and I'm a techie, so there was a problem. Every time we had a hard rain, the ground fault would throw. Like the circuit would open, and I don't have any lights outside because I'm not really that handy. So the circuit opens up, so now nothing's happening. No electricity is getting to my lights. So I go to the box, and I hit the reset button, right? The circuit closes. Well, there's water in there. It pops back open. So I wait an hour, or I get a shop vac and suck the water out of the electrical line because I don't know what I'm doing. And then I hit the close button, and it tries again, and it pops like, oh my gosh. So I try again. It's a really funny story, too, because it turns out it was an extension cord. It wasn't my wiring. So finally, you do it, and it shuts, and everything's good, right? The power's good. The circuit breaker pattern in distributed processing, and let me start by this. The containers are great, right? And all this stuff's great. But then what you're doing is you're morphing into this world of distributed systems. And then it brings another, they're not problems, but they're considerations. Logging and performance monitoring and the circuit breaker pattern. Like if you have multiple services, one calling the other, let's say A, B, C, D, and E, and C is down, what happens to your system? Like, oh man, we're sunk because of one stupid microservice. I thought these things are supposed to be great. So you have to come up with a way to get around it or account for it. The circuit breaker says, as long as I'm hitting the server and everything's good, we're cool, everything's great. But let's say there's a problem on the server end, and not just that the server's down. Let's say that my favorite one is the server is slow. So you're hitting the server, and it's slow, and you're not happy with that, so what do? You just hit it again, right? You keep trying and trying and trying. So you're making the problem worse, right? Like, this hurts, so I just keep pushing on it until it gets worse. So what you want to do is you want to say, I want to stop access to the server for a certain amount of time, give it a chance to recover, and then I'm going to try again, and if it fails, I'm going to go back to my, okay, open state, wait again, try, wait again, try, success, oh, we're good. So the circuit breaker pattern does that, and I use the Poly project. One of the things I want to point out is if you look down here in the right-hand corner, it targets Net 4.0, Net 4.5, and Net Standard 1.0. Nowhere in does it say .NET Core, yet it works in .NET Core. That's something to be mindful of when you get into .NET Core. Just because something doesn't say .NET Core doesn't mean it won't work, right? So keep that in mind. So the Poly project is going to say, and you configure this as a developer. In my example, I think I have a 4-second timeout. That if the server takes more than 4 seconds, it says, you know what? I'm just going to back off and not try. And then it waits 8 seconds of trying, and then it tries again, and if it's successful, it keeps going, and if not, it goes back, it starts over another 8 seconds. Right? We got that. Some interesting things, if you back off for 8 seconds, and 2 seconds into it, the server recovers, you still wait those other 6 seconds, right? You program that in. It's all up to you as a developer to put in what you want. But what you can do, because it's under your control, if the circuit's open, you can provide like a fallback position or a default value. The example that I was given is if you go into Netflix and you sign in and you get recommended movies, right? And they're based on your patterns of watching movies. And before they had now they have the different, like who's watching, right? You have multiple profiles, and before they didn't. So my wife and the grandkids would be watching movies, and I'm like, I think I'll go watch a movie, and it comes up like Teletubbies and Penguins of Madagascar. I'm like, I really kind of watch Pirates of the Caribbean. So if it doesn't have your personal recommendations, it'll just give a default recommendation if that service is down. But you don't know it. So there's a good example of like, well, the circuit's closed, but the user doesn't have to know. So I just wanted to let you know about the Poly project. I use that, and it works real well. So I have an application over here. It's called Howdy. And you get one guess what it returns as a RESTful interface. It returns Howdy. So I think I have this built. Docker run. We'll find out here if I have to build it. Okay, it's running up there. If you've not used Docker, a humorous thing is when you run something, if you don't give it a name, it makes them up. See the sad swirls? It makes up these awesome names. So there it is running. Docker, I'm going to run that again just to make sure it didn't crash. And why would it crash? I want to bring this up. It runs on port 5000. If I run another application in Docker on port 5000, it'll crash. Because you can't run two applications on the same port, right? But if you use Kubernetes or OpenShift, you can run as many apps as you want on the same port, and it manages that for you. So there's another cool thing. You don't have to say, well, we have this book or this spreadsheet that this application runs on port 80 and this runs on port 83 or whatever. You can just assign them all to port 80 and let it sort it out. So that's cool. That's added. So now it's up and running. So theoretically, if I go over here and the path is greeting, I should get Howdy. So this Howdy has two settings now. I have a slowdown that mimics the server being slow, and then a normal, which brings it back. So I have a watch. Oops, excuse me. No, I'm sorry. I'm going over here. Circuit breaker. I also have a circuit breaker app. And it's a console app. And I don't need to go into the code because two reasons. One, today is not to get gritty. It's to show you what's possible, and then you can run with it. And everything I have is in a GitHub repo. You can get it, download it, play around with it all you want. So there it's doing like a curl. It's getting a request. So it's running Howdy. So Howdy's fine. So everything's going. My microservices is returning, you know, whatever, my location based on my IP address or whatever. And then let's just make this fail, and then we'll be done. So if I set this to slow down and go back here, now the circuit, and now the circuit's broken. So it's, every time it says broken circuit exception, it's not hitting the server. So that's the perfect example of it. And now I go back here and run normal. Now again, it has to wait the 8 seconds. So even though things are back to normal speed, the circuit's open, it goes what's half closed, it tries to, and it's back up. So that's the circuit breaker pattern. So those are the things you can do today with .NET Core and containers and Docker. Now Scott is going to talk about what's coming up with .NET Standard 2.0, and I think it's going to be pretty cool.
I'm Scott Hunter, and I work at Microsoft on .NET. We got a couple other guys in the back of the room. We got Matt Ellis over here, hand her up. We got Stephen Tobe here as well. So if you have any questions on .NET after the session, please find those guys. And I'm going to do a quick intro of some of the stuff we have coming up next week for you guys. So we announced this thing called .NET Standard Library about a year ago, actually. And we shipped the first one in June, actually. And the idea behind .NET Standard was, over the years, we built a lot of .NETs. And each of those .NETs had different API surfaces. And the goal with .NET Standard was to actually have a consistent API set across all the .NETs, whether that's Xamarin, whether that's .NET Framework, whether that's .NET Core, which you would be using if you're running .NET on Red Hat. And so that's one of the big goals of this. .NET Standard kind of replaces something we had before called portable class libraries. This was the way we shared code in .NET before. Portable class libraries had a challenge because as you added more frameworks, the surface area got smaller and smaller and smaller. And so that was one of the goals we wanted to solve with .NET Standard 1.0 that we shipped. Another thing is there's a challenge that we had with .NET Standard 1, which was if you're using .NET Core today and you're trying to port an application from .NET Framework, you're going to find a lot of APIs are missing. And so we're working on that, and I'll talk about that in a second. So this is just a chart kind of showing you the goals of .NET Standard, which is all the .NETs, whether it's Windows Desktop, whether it's cloud, microservices, that would be your Red Hat, whether it's Windows UWP, whether it's iOS or Android or games, they all have the exact same .NET. And we have the same set of tools, whether it's VS, VS for Mac, or VS Code, all of those all work the same way with all this technology. That's kind of cool. The big thing is we are going to, next week, ship a preview for the first time of .NET Standard 2.0. And as you can see over here, we're basically adding about 20,000 APIs back to .NET Core, or to .NET Standard, which .NET Core will actually implement. And right now, if we do an analysis of NuGet, about 70% of all the packages in the NuGet gallery actually can run on .NET Standard 2 because enough APIs are brought back. And so if you're a customer that's trying to move some .NET Framework code to .NET Core on Red Hat, this is going to be a huge boon for you because a lot of the stuff that's the .NET's going to run on Red Hat at this point. This is just an example of some of the API sets that come back. All the XML, all the serialization, all the networking, all the I/O, threading core, tons and tons of APIs are coming back. I think you're going to really enjoy it. This is important as well, is with .NET Standard 2, we also have a new version of .NET Core coming out as well, which is .NET Core 2.0. Once again, there'll be a preview of this available next week, I hope. And the big thing that .NET Core is going to do is it has support for .NET Standard 2.0. It's got the notion of simplified packaging. It used to be that you would acquire .NET Core, and you had to acquire things like ASP.NET and Entity Framework separately. We're going back to a model where everything has been one big framework, and you acquire .NET Core, and you'll get all the technology. For things like ASP.NET, we have this notion of what we call automatic diagnostics. This is today, if you run an ASP.NET application, there's a whole bunch of configuration you have to do for diagnostics. This will just happen directly in VS and in VS for Mac. And from command line, you'll still have to do some work, but it'll be automatic in the IDEs. We're bringing back a great framework for building SPA-type applications called Razor Pages. It's a simplified MVC where you don't have to have all the stuff. And we have another framework that we had called SignalR we had running on .NET Framework that we're bringing with this as well. So a lot more compatibility, and a lot of the missing features that we had from .NET Framework are coming with this. This is an example of what an ASP.NET application looks like today in .NET Core 1.0. And notice you have to know a lot of stuff to boot all that up. That same ASP.NET application today with .NET Core 2.0 looks like this. I reference .NET Core, I reference ASP.NET, and I'm done. So that's kind of the simplified packaging. I wanted to talk about one other thing as well, which is I saw some hands go up earlier, people that use Visual Studio. People using VS. Who has a Mac? So if you're a Mac person today, typically the way you'd build .NET Core applications is with VS Code and command line. We announced in November Visual Studio for Mac, and we'll have a preview of this, I think, next week as well. And this is a preview of VS for Mac that basically has a lot of the same experiences that you have in VS for .NET Core in VS for Mac. Before I even talk about that, I want to highlight we are going to try to make these products exactly the same, meaning that if you're using, you'll get the same project templates. If you're using our HTML, CSS, or JSON editors, they're the exact same code base from Visual Studio, so they'll behave exactly the same. The backend debugger is the same backend debugger across both products. And all of our Azure Publish infrastructure is the same as well. Sometime later this year, we also plan to bring the same JavaScript editor from Visual Studio for Windows and the same Razor editor for ASP.NET Core applications from Visual Studio for Windows as well. So the idea here is whether you're on Mac, whether you're on Windows, you get the exact same experience. With that preview that will come out next week, you're going to get all of the ASP.NET Core, the console, test templates will be built in. You're going to get container support with debugging built in. So if you want to build the same kind of containers that Don was showing a second ago, you can now do that in VS for Mac on the Mac. And you get all of our publishing to Azure as part of this as well. And if you're a Red Hat customer, which why you should be here, we hope to have a preview of .NET Core 2 shortly after the Microsoft Build Conference next week. And then we're trying to plan to have this .NET Core 2 stuff, RTM, sometime in the July timeframe. So this is VS for Mac. And inside of this, I can basically do new solution. And now we've got this .NET Core section down here. And I can select, you can see all my templates. I've got my console, my ASP.NET Core projects. I've got my tests. I'll go and select an ASP.NET web app. Give it a name. Create it. And you'll see the same kind of Explorer interface that you would expect in VS over here on the left. And for fun, I will actually go and right-click on the project, and we should have, if I am lucky, this is that Docker support. I can add Docker support here. Don't know if it'll let me zoom in on that. It will actually. So I got my ASP.NET Core application in VS for Mac. I'm going to add Docker support to it. And then what I'll do is I'll open the controller file up here. And I will see if I can zoom a few of these things in. I'll put a breakpoint over here. And let's run this and start debugging. So what's going to happen here is VS for Mac is going to go out and create a container. And we should be able to see that from terminal over here. You can see that actually, good. So there was my Red Hat project. Oops. There I am running in a container. And let's go back to VS, and I put that breakpoint on the about. Let's try hitting about. Boom. So I'm actually running in a container, debugging in VS for Mac, on a Mac, obviously. So the goal for us is, there's my container. If I go and show the processes, you can see the process running. So I'm running that app right there. right from VS for Mac. And so you'll find the actual experience is pretty dang awesome. Once I've got that going, let's stop. And I'll start it up again without debugging. It's pretty quick. Just take about 7-8 seconds to boot back up and move the browser back up again. So great experience developing live in the container. So I can actually, you'll be able to in the future actually develop live in a Red Hat container in VS for Mac on a Mac. And so that is some of the VS for Mac stuff that we have. And we are out of time, I think, actually. So Don, do you want to come up and see if we have any questions? So, well, so the question he was asking was, in his world, he's trying to move away from IIS and actually run his .NET Core applications with Kestrel bare metal, is what I would call it, when you run Kestrel right on the edge of the internet. So we are going to say in the .NET Core 2 timeframe that is a fully supported model. We're doing all the security testing on Kestrel right now to basically say it's safe to be on an edge. Today, if you're on a Windows machine, we actually do by default run it behind IIS, because IIS does offer some protections where it'll do some canonicalization of URLs and stuff like that to make sure the bad URLs don't get through to the actual process underneath it, whether it's PHP or Node or .NET. But we are doing all the testing on Kestrel right now, and so in that July timeframe that we actually RTM2, I'm going to say it's okay to run Kestrel wherever you want to. So that's a popular question for us. The question is, you've got some applications running on WCF. We have some stuff that right now, what I would say the answer is we don't have any plans to port WCF to .NET Core. And part of the reason is, if we keep porting stuff like that, where do we stop? I could bring System Web, I could bring WCF. Right now, we kind of envision ASP.NET Core and .NET Core and EF Core to be the way to build new modernized container applications. That said, there's lots of folks with legacy code. We do have internally some shims that make it easy to take some of your existing WCF code and actually run it on Core. If you find me afterwards, my hope is sometime later this year to make those shims available on GitHub. So if you want help porting your code, it makes porting your code a lot easier. Come find me afterwards, and I'll give you a copy of the shim code. I will have to defer to these guys on when that's going to happen. But here's what I would say is, for like my current non-Red Hat images, I do actually have images where we actually put the shared framework into the container itself today. So we're not actually doing, in the case of the containers that we have outside of Red Hat, we actually have the shared framework there, so you only publish your application to the containers. I don't know if you guys have a plan.
So is the question that, how do you get
here's the question. There's two ways to publish a .NET Core application. One is what we call a standalone application, where all the DLLs are part of the publish. And then there's one where you actually just have the shared framework, and you just publish the actual application itself.
Yep.
So it's less stuff to publish in the case of having a shared framework. Is that the reason you want this? Because it's a faster publish, because there's less stuff to shove into the container? The hope is that we have the F# stuff done in the 2.0 timeframe before the 2.0 stuff RTMs this summer. So, and you're right, there is still a long list of stuff. It's not that big. I actually saw the list right before I came here. It was pared down pretty well. So, but the plan is to hopefully have full F# support by the summer.